Example 2 requires us to use the results of example 1 to show that the cosine of A minus B can be given by the cos A cos B plus sin A sin B. Using these results. These are the results of example A. I've just brought them on board because we are going to use them in explaining example 2. What do we know about the cosine as a result of example A? All we know is that the cosine of A plus B is given by the cosine of A times the cosine of B minus the sine of A times the sine of B. That we know. But if you look at this and this, there's a difference in such a way that in this one, B is negative here. So let B be negative B. So what are we saying? We are saying that in the cosine of A plus minus B, and you know what this gives us? Plus minus means minus. Is supposed to be equals to, in this general relationship that we know, is supposed to be equals to the cosine of A times the cosine of minus B minus the sine of A times the sine of minus B. The first aspect, the first level gives us on the left hand side, we have the cosine of A plus minus B, the cosine of A minus B is equals to what? Before we do anything, it is important to resort to the unit circle, the one we know, the one we talk about all science teachers complaining. And we know very well from the 0 degrees, negative B is an angle that heads to the clockwise direction, and it is obviously going to be in the fourth quadrant. And in the fourth quadrant, assuming that is B, you can see only cosine is positive. The rest are negative. So let's see. The cosine of A is not, and the cosine of minus B, you can already see that the cosine of minus B is positive in the fourth quadrant. So it remains the cosine of B. Minus the sine of A. Now the sine of negative B. The sine of negative B is negative in the fourth quadrant. So minus the sine of B, it's already negative. Already you can see, if you open this bracket, you're going to have minus times minus is going to be positive. So what are we saying? That the cosine of A minus B is equals to the cosine of A times the cosine of B plus the sine of A times the sine of B. Remember, if you open this bracket, we have the sine of A times this negative the sine of B, which gives us positive sine A sine B. And if you look at what you're supposed to show, this is exactly what you're supposed to show, hence shown. If you look at part B, we are supposed to prove that the tangent of A plus B is exactly equals to the tangent of A plus the tan of B all over 1 minus the tan A tan B. And again, we said we don't know anything else apart from this. And all we know is the tangent of A plus B can only be given by, of course, from the very primary trigonometric identity, we know that the tangent of theta is the sine of theta over the cosine of theta. That we know. And we bring that knowledge here and talk about the tangent of A plus B is the sine of A plus B all over the cosine of A plus B. Luckily, we have these expressions there, which means sine A plus B is sine A cos B plus cos A sine B all over cos A plus B is here all over cos A cos B minus sine A sine B. Now we have the numerator and the denominator. And if you can see, we are supposed to express this one in terms of tan A plus tan B. So at the numerator, we must be left with tan A plus tan B. How do we make this tan A? We must be prepared to divide the whole of this by cos A cos B. Why cos A? And if we divide this one by cos A cos B, to be left with tan A, it means we must do the same in the numerator as well as at the denominator. So dividing both numerator and denominator by cos A cos B. Let's do that. If we divide both the numerator and the denominator by cos A cos B, we have the following. We have the following. This is tan A plus tan B. We have the following. Sine A cos B all over cos A, this is now the numerator, cos A cos B plus cos A cos B all over cos A, this is cos A sin B, cos A sin B rather, cos A sin B divided by cos A cos B all over, that is the numerator. What about the denominator? What does it give us? Cos A cos B all over cos A cos B minus sin A sin B all over cos A cos B. All these are brackets which are very independent. If we may wish to work on the brackets, we are going to have, if we cancel out cos B and cos B, we'll be left with sin A over cos B, which is tan A, plus cos A sin B. Cos A cancels out with cos A. Then we are left with sin B over cos B, which is tan B. Let's just follow, which is tan B, which is the tangent of, which is tan B. Tan B. That is the result of the numerator. Look at the denominator. Cos A cancel out, cos B cancel out, 1. Minus sin A over cos A, sin B over cos B, or rather sin A sin B over cos A cos B. This one is by itself tan A, and this one is by itself tan B. So we are going to have tan A tan B. And this is exactly what you're supposed to show. So in other words, the tan of A plus B is exactly equals to what we have shown there. At the end of the day, it is important to highlight that we have been able to prove that the tangent of A plus B is exactly equals to tan A plus tan B all over 1 minus tan A tan B, as shown there in red. All right?